What's going on, everybody? Our Chapter 9 review before we take our Chapter 9 test next week. This is just a bunch of example problems similar to what you will see on the test. So let's go through it. Okay, vocab. I want you to name the give an example of the vocab word. That's what I'm trying to say. Again, best practice of doing these review videos would be to pause it, try and answer them on your own before I give the answers. So if you want, go ahead and pause the video right now, look through the questions and see if you can come up with the answer. If you paused it, great. If you didn't, let's go through it, right? A radius, an example could be segment AH, could be segment AF, right? There's multiple different answers. A diameter would be segment HF. A chord passes through the circle, so that would be segment DG. A secant line goes through a circle, that would be line BD. Remember, there's a difference between segments and lines, so that's line BD. Point of tangency would be here at point H, right? The center here is at point A. Inscribed angle, that would, there is just one actually example here. So inscribed angle means the angle happened, there's more than one, but an example would be angle BDG, angle BDG. And an arc, there's a bunch of different arcs, right? You can name arc HG. Remember the symbol for arc is here, arc HG. That's a bad G, but it's G. Bunch of different examples for that one. All right, so there will be a section on the test for vocab. Okay, arc measure, you have to be able to find the arcs, the values of the arcs. I'm not going to do all of these, right? But know that if there's ever a diameter, that means it gets cut in half. That means this entire part here is 180, which means that 45 plus 70 plus this part has to give you 180. So if I do 180 minus 70 minus 45, that leaves us with 65. So that means that piece has to be 65. If I use a different color, we see that these angles here are vertical angles. So that means that has to be 70 degrees. And once again, going back to this being a diameter, right? Or if we use then a third color, we also know that AC is a diameter. So that means this part over here has to be 180 degrees. If this is 70, this must be 180 minus 70, which comes out to 110. And you can use this information to be able to figure out any of these arcs, right? So just some examples. Arc BC, well, that one was given to us, so let's not do that one. Arc DB, D to B is adding together 70 plus 65, which gives you 135. That's where the 30 came from. AD is from here to here. It would be 70 plus 45, which would be 115. All right, if I use another color, ACD goes from A. Oh, see, I went the wrong direction. It has to go from A to C to D, so it has to go this way. So that would be 110 plus 70 plus 65. So that's 180 plus 65, which comes out to 245, and so on and so on and so forth. Okay, so there will be, I think there's 3 questions on the test that are similar to this. Circumference and arc length. Okay, remember circumference. Circumference, if I write that up at the top, circumference is equal to the diameter times pi, or if you have the radius, circumference is equal to the 2 times the radius times pi. So here we have a radius, so it would be 2 times 4 times pi. Just use a calculator. 2 times 4 times pi gives us 25.13, so 25.1. All right, over here you have the diameter, so that's just 16 times pi. So use a calculator. 16 times pi comes out to 50.3, or 26, but rounds to 50.3. Okay, arc length. Remember the equation for arc length is arc is equal to the circumference times theta divided by 360. All right, so if we find the arc length here, we know that the circumference is already 25.1. Theta for this is 115. So that means you do 25.1 times 115 divided by 360. Make sure you put 115 divided by 360 into parentheses, and the arc length here would be 8.01 or 8.0 if we round to the nearest tenth. All right, here, all right, for arc length, it's the same thing. We know the circumference is 50.3. For theta, it's technically not given to you, but we know that a diameter creates a semicircle, and a semicircle automatically measures 180 degrees. So for that one, we would do 50.3 times, in parentheses, theta is 180 divided by 360, which comes out to 25.12. Or just, if we round it to the nearest tenth, 25.1. All right, and 9.3, tangents and chords. Find, oh, this is a terrible example. I don't know why I included this. So I'm not going to do the example here, but know that tangents create a right triangle. So you automatically know that this is a right triangle. I realize that this is a bad example because we are only given one side, so you can't really do much there. But you will most likely have to use Pythagorean theorem to find one of these side lengths, but this is a bad example. But know that tangents create right angles with the radius and create right triangles from there. Chords, if you see a perpendicular, if it's a diameter and it's perpendicular, that means it automatically bisects those, which means those are congruent. So to solve for x for there, you just set them equal to each other. 5x minus 6 is equal to 2x plus 9. All right, subtract 2x, that gives you 3x. If you add 6, that would give you 9 plus 6 is 15. Divide by 3, x is equal to 5 there. Okay, also remember for segments, chords and tangents, if chords are congruent, that means the arcs are congruent. So if measure of a arc AB is 110, that means you automatically know that arc BC is 110 because the chords are congruent. In the other example, if I switch colors now, if arc AC is 150, find the measure of arc AB. Well, we know that those are congruent, so if that's x, that's also x, and we know that all three of those have to add up to give you 360. So we end up with 150 plus 2x equals 360. 360 minus 150 gives you 2x equals 210. Divide both sides by 2, x is equal to 105. And then you can double check 105 plus 105 plus 150 does add up to 360 degrees. Okay. If two chords are congruent, that means the distance from the center is congruent. So that means these are congruent and we just set it up. 2x is equal to 5x minus 9. All right. Depending on which one you move, I usually say to get rid of the smaller number, but that actually might create more steps this time. So I'm going to subtract 5x. 2x minus 5x gives us negative 3x, which is equal to negative 9. Divide by negative 3, and x is equal to positive 3. There. 9.4, angle relationships with circles. Remember, that's on, in, or outside. If it's on, that's not a great color. Let's go here. If it's on the circle, the equation is just that the angle is equal to the arc divided by 2. Or you can flip it around and be arc is equal to the angle times 2. If it's in, that is that the angle is equal to arc 1 plus arc 2 divided by 2. And if it's outside of the circle, then the equation is angle is equal to the big arc minus the small arc divided by 2. So if we plug those numbers in here, right, we're trying to find the angle. The angle is equal to the arc divided by 2. The arc is 90. So 90 divided by 2, the angle here would be 45 degrees. If I change the color for a different problem, right? We're looking for this arc. This is inside. So notice that's the angle, but that does not match up with these arcs. It has to be this arc right here. So we know that this is a straight line, which is 180 degrees. 180 minus 102 means that that is 78 degrees. So we plug in our numbers. The angle here is 78 is equal to arc 1, which is 95, plus arc 2, which that's what we don't know. That's what y is, divided by 2. So that means we multiply both sides by 2. That cancels there. 78 times 2 gives us 156. So we end up with 156 equals 95 plus y. We subtract 95 from both sides and get that y is equal to 61. All right, over here we're working outside. If we do another color, outside the angle, which is 24, is equal to the big arc, which is 118, minus the small arc, which is x, divided by 2. We have to multiply both sides by 2 again. 24 divided by, or sorry, those cancel. 24 times 2 gives us 48, equals 118 minus x. Subtract 118 from both sides, so 48 minus 118 gives us negative 70. So you get negative 70 equals to negative x. All right, and then you just flip-flop the sign. So that means x is equal to positive 70. All right, that's for 9.4. And then for 9.5, 4 different equations, right? If it's ever a chord, or sorry, 2 chords, you multiply the same lengths of the chord, set them equal to each other. So that ends up being 9 times x minus 3 because they're part of the same chord. And then we have 10 and 18 is this part of the same chord. So 10 times 180. All right, so we multiply across, distribute. 9 times x is 9x. 9 times negative 3 is negative 27. And 10 times 180 is 1,800. Right? So you add 27 to both sides, so you get 9x is equal to 1827. And then you divide by 9, 1827 divided by 9 comes out to 203. So x is equal to 203, which is pretty crazy to think about. Anyways, keep going. If we have 2 secants, that's external times whole equals external times whole. So the external here is 6 times the whole, which is 6 plus 9, which comes out to 15. And that has to equal the other external. We see the other external is 5 times the whole for this one is 5 plus x. All right, and then we solve from there. 6 times 15 gives us 90. Distribute the 5. 5 times 5 gives us 25. 5 times x gives us 5x. All right, 90 minus 25 gives us 65. So that means 65 equals 5x. Divide divide 65 by 5, and we get x is equal to 13 there. Okay, and then the other 2 equations that we need to know, if you have a tangent and a secant, it's tangent squared equals external times whole. So tangent squared comes 7 squared. The outside here, or external, is 5 times 5 plus x. 7 squared gives you 49. 5 times 5 gives you 25. 5 times x gives you 5x. 49 minus 25 gives you 24. So you end up with 24 is equal to 5x. You divide by 5. You don't get a whole number, but that's okay. 24 divided by 5, x is equal to 4.8. Don't be afraid of decimals. Decimals are just numbers. It's all good. And then if you have 2 tangents, they're congruent to each other. So that means 2x plus 9 must be equal and congruent to 3x plus 6. So that's how you set up your equation. You solve for x. Subtract 2x. 3x minus 2x gives you x plus 6. We have 9. Subtract 6. We end up with x is equal to 3. Okay, so those are all examples of what you will see on the test. Make sure you study, ask lots of questions. Go Mustangs.